We have created mountains and valleys. What now? As soon as mountains start to growing, erosion will occur and sediments will be produced, transported, and eventually deposited in subsiding domains. All these components of the system are strongly influenced by precipitation, temperatures, in summary, by what we call climate. Climate is the weather measured over tens of years. It includes knowledge of temperature, humidity, atmospheric pressures, wind, and precipitation. The motor driving climate, as well as many other processes, is the energy generated by the sun. This is a huge amount and is roughly constant through time. Part of this energy is absorbed by the planet, part reflected back into the atmosphere. The balance between these components is key for the Earth climate and has made it possible to keep temperatures on the Earth generally constant and pleasant. To understand climate and climate changes, we need to look more in detail at how energy is transmitted. The energy from the sun to the Earth is transmitted by radiation. This implies no contact between the emitting and the receiving bodies and no significant movement or mass between them. During its travel from the sun, radiated energy will interact with the atmosphere and eventually with the Earth. Energy radiation and interaction with various bodies follow a number of very important rules. All objects absorb and emit radiant energy. Good absorbers are also good emitters. Poor absorbers are also poor emitters. Hotter objects radiate more energy per unit area than cold objects. The hotter the radiating body, the shorter the emitted wavelength will be. The wavelength of the sun radiation, for instance, is much shorter than that of the Earth. Following the rules mentioned in the previous slide, we can now look at what happens to the energy radiated by the sun. Being a very hot body, the sun will emit a very high amount of energy, typically with short wavelengths. Having short wavelengths, the sun energy will easily pass through the gases present in the external part of the atmosphere and will then reach the clouds, which will reflect back to the atmosphere part of the incoming energy. The largest part of the energy, however, will then travel further and reach the surface of the Earth. Energy hitting colder reflective bodies like glaciers and water masses will be essentially reflected back. On the whole, this energy is not very much. A substantial amount of the energy, roughly half of the incoming amount, will interact with the continents. Soil, vegetation, and so on will absorb large amount of the energy and then emit it back. But something very important happens at this stage. Namely, the energy emitted by the Earth has been changed and has acquired much longer wavelengths than the one which was delivered by the sun. This is in accordance with our rule number 4. The energy emitted by the Earth will then start traveling backward towards the high atmosphere, but will then be blocked by clouds and, more importantly, by the layer of greenhouse gases. Because of the higher wavelengths, the energy emitted by the sun can Earth. Energy is then trapped between the Earth's surface and the layer of the greenhouse gases, thereby creating an overall pleasant temperatures we are enjoying on Earth since millions of years. It is clearly a very complex system with a lot of variables which, however, are closely interlinked, and even small changes can have profound consequences. These fall under the general category of climate change. Here are some examples. The greenhouse gases form essentially a blanket bouncing back the infrared rays emitted by the Earth. An increase in greenhouse gases, like the one we are experiencing now, leads to an average increase in temperatures. Albedo is the percentage of reflected energy with respect to the incident energy. Clearly, glaciers have a very high albedo. Decreasing the surface of the glaciers decreases the portion of the sun energy radiated back to the atmosphere, resulting in an increase in the energy absorbed by the Earth and emitted back as infrared. A third very important component is vegetation. And here things start getting complicated, as vegetation has a twofold effect. Increase in vegetation also increases the emission of CO2, an important greenhouse effect. On the other side, when plants die, CO2 is buried as fossil. As you see from the diagram, there have been important changes in temperature in the past. Indeed, climate has always been changing, and this has happened over a multitude of temporal scales. Changing climate has had a major impact on the type of sediments, living conditions, and many other features. At present, we are facing an additional challenge, namely climate change caused by human activities.